Well, thank you very much, Rich. I'm going to go ahead and share my screen. Can you see it okay? Great.
Yes, we can see it.
Okay. Well, hello, everybody. I'm David Hooper, founder of ELDÆON. We build production-ready multi-sensor detection systems for UAP and unknown aerial objects. What you're about to see today are not concepts or lab prototypes. These are real, deployable systems you can order and run today. Let me go over the problem briefly. The problem in UAP detection is really an infrastructure crisis. The infrastructure is fragmented. Single sensors, no shared standards, no validation, and almost all the high quality data is classified. So what does that mean? Civilians, universities, and even law enforcement or government don't have independent instrumentation. We at ELDÆON decided to build production infrastructure that solves that at two scales. ELDÆON operates as one platform with two systems. Dionysus is the enterprise multi-sensor validation system, and Nemesis is the distributed passive radar node that builds the network. One validates with many sensors. The other provides geographic coverage. Together, they form a civilian detection network instead of just isolated instruments. So let me start with the validation system. Dionysus. It's a production multi-sensor detection system, 28 synchronized sensors across 6 modalities: audio, electro-optical, radio frequency, quantum, environmental, and even biometric. It's a distributed compute architecture with a real-time cloud dashboard. This is built to be deployed in the field and generate verifiable events. You can see here a product spec sheet of the system and a few highlights and characteristics of the Dionysus. The key idea is correlation. Any single sensor can be wrong, but when multiple modalities agree with synchronized timestamps, we can validate events. We use GPS discipline timing across the system and atomic clock reference synchronization for high precision correlation. What this lets us do is align radar returns, optical detections, RF emissions, and even environmental baselines into one timeline. Instead of just one computer doing everything, we distribute workloads. Edge devices handle cameras and sensors. Everything syncs into a cloud dashboard. That makes the system resilient, modular, and deployable anywhere. I'll show you a short overview of the system in operation.
So this is the UAP detection dashboard. Right here you can see several of our cameras. You can see the PTZ camera, all sky camera, thermal camera, and UV camera. You can also see some readings coming from the sensors on board Dionysus. From the GPS you can see the altitude, you can see the electromagnetic field strength, RF levels, system status, and alerts. Here's some more of the sensor feeds coming from Dionysus. Sometimes we get a signal loss because of Wi-Fi or internet connectivity issues, but signal definitely picks back up. And that's why it's important to have fail-safe measures and auto recovery measures. And so yeah, you could see counts per minute from the Geiger counter. We have 2 tubes, so you can see both of them here. Going over to the spectrum analyzer, going from around 0 to 6 gigahertz. It's basically a frequency scan of the local radio environment to see the power output levels, so you can see what's broadcasting in the area. And then you have a real-time waterfall showing over time what were the intensities of the power outputs at different frequencies. On board Dionysus, we also have an ultrasonic microphone that goes up to 192 kilohertz. You can see that here, the spectrogram on the bottom. We partnered with a company called Weird Technologies, and so we've used their patented algorithms to show conscious intention, how we can pick that up, and how it relates to interacting with UAPs. So these are two random number generators that are outputting random zeros and ones, and you can correlate these two outputs through different means, and you can see when anomalous events take place. We have a muon detector on board, basically two scintillators that are being compared, and when a particle passes through both of them at the same time or very close in time, it's a coincidence. That's what it's called. So that's a cosmic ray. And so you can see the flux, the counts per minute of that cosmic ray, and this is the raw ADC values from that device that's on board Dionysus. We have our passive radar system listed here from Dionysus so that you can see returns from objects flying overhead, and you can see the ADS-B ground truthing from these orange objects. It's also showcased here in a separate view. You can see different types of airplanes that are flying overhead, and you can get information. And we're receiving this data directly from the transponder that's on the airplanes, and that's ADS-B. You can see some of our sensors here that are part of the Dionysus system. And then moving over to Nemesis, which is our consumer passive radar. This showcases the low-cost $500 consumer product that we're ready to ship for beta testing for first few customers who would like to try it out. Definitely reach out to us if you'd like to purchase one and be interested in beta testing. We also have some preview features of what we plan to do in the future. So with multi-static radar, what that is, when you have multiple nodes, you can actually triangulate in 3D space objects. And so that's what the multi-static approach is. And what I can actually show you is if you were to set up a Nemesis node in San Francisco, one in Oakland, and one in Berkeley, what you would be able to do is actually triangulate unknown objects. And you can get a 3D position of those objects using multiple passive radar nodes, such as Nemesis. And so this is a preview of what's to come when we have enough nodes out there. So the first 10, will be part of the network. We have some functions to export radar tracks, so you can see all the different types of radars, whether they be unknown objects or aircraft. Other types of export features for ADS-B, device health, alert histories. These are in preview mode right now. And then the raw console output from the Nemesis device. And then now we have Sotera. Sotera is a satellite tracking application. It's also on iOS. And so the premise is when people go outside and look at UFOs, you can probably figure out which one of those are satellites. And so this is a feature to be able to help people turn unknown objects to known objects. And so there's a top-down map. You can change the ground radius here, and you can change the different types of satellites that are shown. You can also do a sky view, show more satellites, and then these are all listed in case you like to view them that way. We can also change the source of the input for where it's localizing and where it's generating the satellites. So it can come directly from the Dionysus sensor or the Nemesis sensor. It can come direct from your actual viewing device when you have access to our dashboard, or you can manually put one in. Let's say you're on the other side of the country, you can put your own GPS location. And in the future, our goal is to have the world's first UAP detection network. So no matter if it's in North America, Asia, South America, Europe, we're looking to expand coverage and provide, you know, humans with the technology to be able to understand reality. And we have some different features here showcasing some of the consumer passive radar maps. You know, if you have multiple nodes and you have different types of targets, you can see them on a type of map here. Also a feature where you would see your nodes. Let's say you own more than one Nemesis passive radar, you'd be able to see it here. You'd also get alerts from your Nemesis passive radar system, and then you have your settings. Let's say you want to change the reference channel for the passive radar configuration, you can do that here. And you can also change settings in your account for your information or subscription. We plan to have a low-cost $20, $19 a month subscription service for people to have access to cloud storage and for us to be able to release new cloud features for the devices that we sell, as well as for the enterprise system, which is Dionysus, have some enterprise features as well that we can grow revenue with and actually be a profitable business so that we can continue making products for researchers and people in the UAP community, as well as integration with API keys so that, let's say you want to connect with a different data source, or if you want to export your data, you should be able to do that no problem. And that's it. Oh, actually one last thing. We have an AI assistant, so you can ask it, what is this dashboard about? You can ask it questions about what's on the dashboard and it can help you. So yeah.
Okay, so what you just saw is live output from Dionysus and Nemesis using the cloud dashboard. These are some of the standards, methodologies, and architecture design choices about the dashboard. As for Dionysus, what it really is are multi-sensor streams aligned in real time, standardized exports, APIs for researchers. This is infrastructure designed to share data and enable validation across organizations. But enterprise systems that cost a lot of money don't solve the coverage issue. So that's why we have Nemesis. Nemesis is the distributed side of the network. It's a $500 passive radar system that detects aircraft, drones, and non-cooperative targets using existing broadcast signals. There's no transmission, it's fully passive, deployable by civilians and researchers. One node is useful, but 100 nodes creates the coverage that we really need. So you can scan that QR code and sign up for the first batch. We'll be delivering them in Q1 2026. And so I have a very short demonstration of the passive radar. I will narrate this now that I know that audio is not coming through. So what you can see here is radar tracks as well as ADS-B. And that ADS-B blue dot is a real airplane, and we can see it being correlated with the radar return over time. And so what we can really do here is do ground truthing. We can rule out known objects and then focus on the anomalous objects by looking at the radar returns that don't correlate with ADS-B returns. We can also change the noise profiles to clean up the signal. We can do, really, the goal with this is to give people the data to gather data on their own. And you guys can purchase this now. Most people don't have access to high quality UAP data, other than their cellular phones that have UV IR cut filters. So this will really change the game for a lot of people. It'll give them a type of data source that is usually reserved for people that can either afford high cost systems or government and military. So we've already had a lot of speakers talk about how passive radar works. I'll be very brief. Nemesis provides detection coverage across geography, and Dionysus provides validation with multi-sensor fusion. And when multiple Nemesis nodes observe the same object, we can actually triangulate them in 3D space. And when a Dionysus node observes it, we can validate it across the different modalities that it has, over 28 sensors. And that's how you really build independent detection infrastructure. You take the best of a high quality system that has multiple sensors, and then you use many low cost, niche, a very specific technology for detection, and you spread them out. So that's our approach. And here's calibration and tracking in action of our Nemesis passive radar system. So what you can actually see here is the surveillance channel antenna is mounted on a pan tilt head. You can change the bearing, and you can also change the pitch so that we can get the best signal for the returns coming off of objects seen in the sky. And everything is inside of the case that you see there. Power over Ethernet, has ADS-B. It's a really fine-tuned system to be able to get radar returns. These are some technical specifications of Nemesis across hardware, software, and data output. It's low-cost hardware, open source software, and easy to work with data formats. Everything is built on open standards, open source tools, simple data formats. It's GPS synchronized, so the timing's stellar. So multiple sites can correlate detections and even localize objects across the network. Data stays local by default. We do have optional secure sharing for teams that want to collaborate and post to the cloud dashboard. And the long-term goal is a distributed civilian detection network, enterprise validation nodes, consumer radar nodes, shared data standards, and opt-in collaboration. More nodes means better coverage and better triangulation. There's 3 ways to participate in the ELDÆON network. You can purchase a Dionysus system. That's more for research labs. Not everyone can afford that. I totally understand. So that's why Nemesis is really a game changer. For only $500, you get impressive radar data that for most people, they've only dreamed of. So batch 1 sign up, there's a free wait list, a $50 deposit if you do want to join the priority queue. It's a total cost of $500. Scan that code. And as far as collaboration, let's integrate platforms, right? Share data, solve this together, reach out to us so we can partner together, and you leverage our cloud software. One more thing, Sotera. I do have maybe like a minute. It's an AR app to rule out known objects in the sky so we can focus on the unknown. Basically, point your phone up in the sky and you get real-time satellite tracking in augmented reality. So Dionysus, our enterprise system, detects. Sotera tells you if it's just a satellite. So scan that QR code to learn more. It'll be on iOS soon. And then I'll close off with a quick demo of Sotera. So this is Sotera. It's ELDÆON's first iOS app. The premise of Sotera is to help everyday people make unknown objects known. And really, the easiest way to do that is through satellites, right? Most people report UFOs, and they're really just satellites. So what I'm doing here is turning on Starlink, seeing all the Starlinks overhead. We can actually see the phone and the app move with the orientation. We can also see different satellites that we can turn on selectively, off or on. And we can also change into sky view mode, which gives us the option to see upwards and see the satellites that are in the sky. You can actually click on one of the satellites and get more information, so you can rule out known objects. But the best feature, my favorite feature of all, is the augmented reality feature, so that you can actually point your phone camera up in the sky and correlate, that's not a UFO, it's just a satellite. And so I think this will be really helpful to the community. And thank you very much. Our systems are deployed, dashboard is live, and we're ready to support humanity with technology to one day solve the UAP detection problem.